Welcome back to our deep dive into computer science and software engineering.
This time, we're cracking open Matters Computational
Yeah.
to explore algorithms,
Okay.
number theory, and permutations.
It's a trio.
A trio that might sound abstract,
Right.
but actually powers so much of the software that we use every day.
Exactly. And the excerpts you've shared are like a crash course in computational thinking,
Yeah.
filled with clever techniques and code snippets. For example, one thing that caught my eye was this method of replacing division
Okay.
with multiplication and bit shifts.
Interesting.
It seems counterintuitive, but the book claims can make calculations significantly faster.
That's because division, especially by a constant, can be a computationally expensive operation for a processor.
Right.
Think of it as a long, winding road.
Okay.
Multiplication and bit shifts, on the other hand, are like taking a shortcut.
Okay.
You get to the same destination, but with fewer steps.
So the code example in the book shows how to replace division by 10,000 with a series of multiplications and right shifts.
Yeah.
Is this something programmers actually use in real-world applications?
Absolutely. Imagine you're building a high-performance graphics engine for a video game
Okay.
where speed is crucial.
Yeah.
Optimizations like this can make a huge difference in rendering complex scenes smoothly.
I see.
Or think about scientific simulations that crunch massive amounts of data.
Okay.
Shaving off even a tiny fraction of processing time per calculation
Yeah.
can save hours or even days in the long run.
Wow, that's a great way to illustrate the impact.
Yeah.
It's amazing how such a seemingly small tweak can have such significant consequences.
It is. Yeah.
So we've seen how to optimize division.
Right.
But what about something as basic as counting?
Yeah.
The Matters Computational excerpts also delve into efficient ways to count the number of 1 bits in a binary word,
Yeah.
something called population count.
And what's fascinating is that instead of checking each bit individually,
Right.
which would be slow for large numbers, there are algorithms that group bits together and count them in chunks.
Uh-huh.
This makes the process much more efficient, especially as the numbers get bigger.
The book showcases a function called bit count
Yeah.
that uses bitwise operations to achieve this.
Yeah.
I have to admit, some of the code looks a bit like hieroglyphics to me,
Uh-huh.
but the concept of breaking the word into chunks to count efficiently,
Yeah.
that's brilliant.
Exactly. It's like organizing a messy room by dividing it into sections and tidying each one up separately.
Okay.
It's a classic divide and conquer strategy
Right.
that shows up all the time in computer science.
So we can optimize division and count bits efficiently.
Yes.
What else can we do with these clever techniques? The source also mentions a function called revbin
Okay.
that reverses the order of bits in a word.
This is where we see different approaches with potential trade-offs.
Okay.
The source presents two methods, one using bitwise manipulation
Okay.
and another using a loop. The bitwise method is like performing a synchronized series of swaps,
Uh-huh.
while the loop method is like carefully rearranging a line of objects one by one.
It makes me wonder which method reigns supreme in the speed department on modern hardware.
That's a question that often sparks lively debates among programmers.
Right.
It depends on factors like the specific processor architecture
Low.
and the size of the word being reversed.
Yeah.
There's rarely a one-size-fits-all answer in computer science.
That reminds me of something a professor once told me.
Okay,
The best algorithm is the one that solves your specific problem most effectively.
that's a good point. Yeah.
Speaking of problem solving,
Yes.
the source then introduces us to the intriguing world of gray codes.
Gray codes have this unique property where consecutive values differ in only one bit position.
Right.
This seemingly simple characteristic unlocks a world of applications.
The source demonstrates how gray codes can be used in a function called gray rev permute to generate permutations, which are essentially different orderings of elements.
It's like having a map that guides you through every possible arrangement without ever getting lost,
Right.
or revisiting the same spot twice.
Right.
The efficiency and structure they provide are invaluable in many areas of computer science.
And it's not just theoretical either.
No.
The book mentions that gray codes are used in real-world devices, like rotary encoders, to represent angular positions.
That's a great example of how an abstract concept from number theory finds its way into the design of physical systems,
Yeah.
ensuring that even with minor reading errors, the interpreted position remains accurate.
Right.
It really shows how intertwined these fields are. Now let's venture into the realm of multisets.
Okay, I'm all ears. What makes multisets so special in the computational world?
Imagine you have a bag of marbles.
Okay.
But unlike a regular set where each marble is unique,
Right.
you can have multiple marbles of the same color in a multi-set.
Okay.
It's this allowance for repetition that adds a new layer of complexity when dealing with permutations. Ah, so it's like arranging a sequence of colored blocks where some blocks share the same color.
Precisely.
Simply shuffling them around wouldn't guarantee unique arrangements.
Okay.
Swapping identical blocks would result in essentially the same permutation.
And Matters Computational highlights the need for specialized algorithms to tackle this challenge.
Okay.
These algorithms must be smarter, able to discern true unique permutations from those disguised as different due to repeated elements.
It's like these algorithms have a built-in duplicate detector, ensuring only genuinely unique arrangements make it to the final list of permutations. This deep dive is really opening my eyes to the intricate considerations behind seemingly simple tasks like counting and rearranging.
And that's the essence of computer science, isn't it?
Yeah.
Breaking down complex problems into manageable steps and devising elegant solutions.
Right.
We often take for granted the efficiency and speed with which our computers perform these tasks.
Right.
But it's all thanks to the ingenious algorithms working behind the scenes. Speaking of algorithms, the source material also delves into generating permutations with specific constraints.
Yeah.
It mentions connected permutations, where no prefix is a permutation of itself.
Yeah.
That sounds a bit abstract. Can you give us a real-world analogy?
Imagine composing a piece of music.
Okay.
In a connected permutation, each musical phrase introduces a new note or motif,
Right.
preventing the melody from becoming monotonous and repetitive.
Okay.
It's all about creating arrangements where no initial segment mirrors the overall order.
Ah, that makes it much clearer. So even with limitations on how we can arrange elements,
Right.
there are still clever algorithms that can generate valid permutations efficiently. It's like having a set of rules for a game.
Yeah.
But within those rules, you can still come up with countless creative strategies.
Exactly, and that's what makes this field so fascinating.
Right.
There's always a new challenge to solve a new algorithm, to discover a new way to optimize and improve.
Yeah.
The possibilities are truly endless.
So we've explored efficient counting, clever bit manipulation,
Yes.
and even the intricacies of generating permutations with constraints.
Mm-hmm.
Where does this computational journey take us next? What other gems lie hidden within the pages of Matters Computational?
Well, one area we haven't touched upon yet is the world of sorting algorithms.
Okay.
From organizing search results to arranging data in spreadsheets.
Right.
These algorithms are the unsung heroes of the digital world.
Yeah.
They bring order to chaos, making it possible to find information quickly and efficiently.
I'm intrigued. What kind of cleverness do these sorting algorithms employ to tackle such massive amounts of data? Do they all follow similar approaches, or are there different strategies for different situations?
That's a great question, and one we'll dive into in our next deep dive.
Okay.
We'll explore the ingenious methods behind algorithms like quicksort and merge sort,
Right.
unraveling the logic that allows them to efficiently organize vast data sets.
Uh-huh.
We'll also uncover how the choice of sorting algorithm can depend on factors like the type and size of the data being sorted.
It sounds like we're about to unlock another level of computational mastery.
Yeah.
I can't wait to explore the world of sorting algorithms and see how they shape the way we interact with information every day.
And beyond sorting, there's a whole universe of algorithms waiting to be discovered, from compression and encryption
Right.
to error correction, and artificial intelligence algorithms are the driving force behind countless technologies that shape our world.
It's amazing to think that behind every app we use, every website we visit, every piece of software that makes our lives easier, there's a symphony of algorithms working tirelessly to make it all happen. This journey through Matters Computational is truly inspiring, revealing the hidden beauty and power of computational thinking.
And as we continue our exploration, remember that computer science is not just about memorizing algorithms or writing code.
Yeah.
It's about cultivating a problem-solving mindset, a way of thinking that allows you to break down complex challenges into manageable steps and devise elegant solutions.
It's like having a superpower that lets you see the world through a different lens, one that reveals the hidden patterns and possibilities within seemingly complex systems. And as we've seen today, understanding even the fundamental building blocks of computer science can unlock a world of knowledge and potential. It feels like we've only just scratched the surface of this computational landscape.
Yeah.
What other fascinating concepts are lurking within the pages of Matters Computational?
Well, remember those multi-sets we discussed earlier?
Right.
Turns out, There's a whole world of algorithms dedicated to generating permutations from them, without those pesky duplicates.
Okay.
It's like having a set of building blocks with multiple copies of some colors.
Right.
You want to build unique structures, not just rearrange the same blocks over and over.
That makes perfect sense. So what kind of clever tricks do these algorithms use to avoid those repetitive arrangements?
They often employ a combination of recursion and backtracking,
Okay.
carefully navigating through possible arrangements and pruning branches that lead to duplicates. It's a bit like exploring a maze,
Okay.
but with the added intelligence of knowing which paths have already been taken.
It sounds like these algorithms are playing a high-stakes game of computational Sudoku, meticulously filling in the grid of possibilities while avoiding any conflicts or repetitions.
Exactly. And this is just one example of the fascinating challenges and solutions found in the realm of combinatorics.
Right.
The study of combinations and arrangements,
Yeah.
Matters Computational, touches upon concepts like K-subsets,
Okay.
minimal change order, mixed radix numbers,
Yeah.
and recursive generation techniques,
I see.
showcasing the diversity and depth of this field.
It's like we've stumbled upon a hidden library filled with ancient mathematical scrolls, each containing a secret formula for solving a specific combinatorial puzzle.
And as you delve deeper into this world, you'll find connections to other areas of computer science like graph theory, probability, and even cryptography.
Wow.
It's a testament to the interconnectedness of knowledge and the power of computational thinking to unlock new insights in seemingly unrelated fields.
So for our listeners who are eager to embark on their own computational adventures, what would you recommend as a starting point?
First and foremost, don't be afraid to get your hands dirty.
Oh.
Experiment with the code snippets from Matters Computational. Try implementing your own versions of the algorithms and see how they behave with different inputs.
Right.
There's no substitute for hands-on experience when it comes to learning and mastering these concepts.
That's great advice. It's like learning to play an instrument. You can read all the theory books in the world, but until you pick up that instrument and start playing the music, remain silent.
Exactly. And don't shy away from the theoretical underpinnings either.
Okay.
A solid understanding of the mathematical foundations will give you a deeper appreciation for the elegance and efficiency of these algorithms.
Right.
It's like knowing the blueprint of a building. You can then marvel at how all the individual components come together to create a functional and beautiful structure.
So it's a balance between practical experimentation and theoretical understanding, a harmonious blend that unlocks the full potential of computational thinking.
Precisely. And as you continue your journey,
Right.
remember that computer science is not just about memorizing algorithms or writing code.
Yeah.
It's about developing a way of thinking, a problem-solving mindset that empowers you to break down complex challenges, identify patterns, and craft creative solutions.
Right.
It's about seeing the world through a computational lens, revealing the hidden logic and beauty behind everyday phenomena.
And with that newfound perspective, you can not only navigate the digital world, but also shape it, create new technologies, and solve real-world problems in innovative ways.
Exactly.
It's like having a superpower that lets you see the matrix decoding the intricate systems that govern our lives.
So to all our listeners out there, keep exploring, keep experimenting, and keep pushing the boundaries of your computational thinking. The world is full of fascinating challenges waiting to be solved. And with the power of computer science, you have the tools to make a real difference.
And on that inspiring note, we'll wrap up our deep dive into Matters Computational. We hope this episode has sparked your curiosity and given you a glimpse into the incredible power and beauty of algorithms, number theory, and permutations. Until next time, keep those computational gears turning.